Hello everybody, my name is Gary Floyd. I am a senior in the Civil Engineering Department, and today I will be taking you through a summary of my technical manual on the engineered design of a residential wood deck. It seems that every year there is some kind of grave story in the news about a residential deck collapse that takes many lives with it. This could be the cause of many factors, but at the base of the problem is a deck that was either poorly engineered or wasn't engineered at all. The majority of decks constructed are done so using wood, but even with the expansive use of wood in engineered design and construction, the same level of concern and precision is not taken as in steel or concrete design. The reason for this is puzzling, but the industry, homeowners included, must adopt similar engineering methods as used in steel and concrete design. Now, the term engineered design may sound cumbersome, but in my technical manual the process has been simplified so that the technical work has nearly been eliminated, so that most everybody interested in the subject can design a deck to meet the International Building Code, or IBC. So, to show you how easy it actually is to design a deck, I'll take you through the process. Before we begin, I think it is best that I give you an introduction into the basic components of a typical deck. Starting with the base of the structure are the footings. These are concrete members that extend into the ground to assure the loads are being transferred from the deck to the foundation. Making our way up, we have the posts. These are attached to the footings and are the main load-bearing wood components of the structure. Attached to the posts are the beams. These are two bi-dimensional lumber and act as an intermediate loading bearing member. Attached to the house are the ledger boards. These are like the beams, but instead of being attached to the post, they are attached to the existing structure. Sitting on top of or attached to the face of the beams are the joists. These are the first structural members that start transmitting the load downward. The area that the majority of people notice is the decking surface. These act as a transition between the non-structural and structural components of the deck. The others, like the guard, are mainly non-structural members for the railing. Now that we have a basic understanding of the individual components of the structure, we can now start the design process. Here's a picture of an existing residential house. As you can see, there's an old deck that needs replacing. The first step in deck design is to understand the surrounding area and structures. Here we have a house. This one is obvious as to where it is going to go, but others aren't. When it is not so obvious, the two main things to consider are the existing surrounding structures, as mentioned before, as well as the existing underground utilities. This new deck will have dimensions of 20 feet by 10.5 feet. Now that the location and size of the deck have been determined, the first design component can be decided. This requires a conservative estimation of the loads that the deck is going to receive. There are two types of loads, dead and live, and both must be determined to assure that the structure is built to withstand them. A typical conservative dead load is 10 psf, or pounds per square foot, while a conservative live load is 40 pounds per square foot. These loads are then used to determine the member sizing and spacing. Throughout this example, these loads will be used. Now that we have our layout, it's time to go into the member design. Starting with the decking, this is one of the simpler selections. Decking should be at least a 1x6 piece of lumber or equivalent load-rated composite. If lumber is chosen, make sure to stain it to assure a long lifespan. That is what we'll choose. Keep in mind, however, that composite decking requires much less maintenance, but with that comes a much steeper price. Next are the posts. Decks are commonly built on 4x4 posts, but to be conservative and to aid in the construction process, 6x6 posts, pressure treated, mind you, will be selected for this example. And what pressure treated is, it is a chemical process that these pieces of lumber undergo to help with decaying and fungal growth. It's just good for if your posts are going to be in contact with the ground. Taking the load from the decking surface are the joists. These joists are typically 2x pieces of lumber, and based off the dimensions of the deck and what part of the country you live in, can span up to 18 feet maximum. First, with the joist design, we must specify the species of lumber. If the deck is being built in or near Colorado, Douglas fir will be the best and most logical choice, as it is readily available. Our joist dimension happens to be 10.5 feet, so we go to this chart below and look up the closest value to 10.5, making sure to round up. Additionally, we must select the spacing of our joist. It looks like we could get by using a 2x10 spaced at 24 inches. However, the decking has to span that 24 inches, and with the dimension that we have chosen, 1x6, will not be able to span this. So we will be conservative and choose 2x10s spaced at 16 inches. The ledger, along with the beams, will take the load created by the joists. The ledger will be attached to the house or equivalent structure using half-inch bolts. Additionally, it must be at least the same dimension as the joists. Our joists are 2x10, so we will select a 2x10 for the ledger. Onto the beams. These will be notched into the posts, as you can see in this picture. What a notch is a section of the post that is taken out to allow the snug fit of the beams. These are typically made up of 1 to 2 pieces of lumber, as you can see there. First, we need to know the spacing of the posts, as these spaces will be our spans for the beam. In the layout phase, these spacings were decided as spacing of 21 inches from the edge of the deck to the first post, and then from the first post to the second post is 84 inches, and from the second post to the third post is 92 inches. So we need to choose the largest span, which is 92 inches, and base our decisions off of that. Keep in mind that using one piece of wood instead of two will always be stronger in this situation, as long as their dimensions match up. Using the table below and a joist span of about 10 feet, we could choose two 2x10s, and that would span 6 feet 6 inches. We have 7+ feet to span, so the use of a 4x10 will allow us to span 7 feet 8 inches, which is perfect. So we will choose that 4x10. Now for the final structural component, we'll make our way to the design of the footings. These are the final step in the load transfer. These are the base of the structure and consist of concrete, as I mentioned earlier. As long as there's at least 2 inches of cover around the post, the sizing of the footing is good. And what I mean by cover is, so you have the post and that goes on top of the concrete. 2 inches of cover means that there has to be at least 2 inches between the post and the outer part of the footing. We'll choose 5,000 psi. Psi is pounds per square inch. Concrete, and a 12-inch diameter footing. Due to the availability of sonic tubes, and what sonic tubes are circular forms necessary in assuring a satisfactory pour of the concrete. You can see a picture of them down there. It's hard to find them any bigger than 12 inches. So we also need to know the depth as well. To do this, we must contact the local government to find out the frost depth. It is 36 inches in Colorado, so the bottom of our footing must be placed below that depth to prevent undergoing the soil's freeze-thaw cycle, which could cause settlement. So with that, I'd like to lead into the conclusion. I would like to thank you for your presence. To seek further information on connections or to take a more in-depth look at the process of designing a deck, take a look at my full technical manual, as this presentation is only a summary of the process. If you have any questions, please feel free to contact me. My email address is down at the bottom right corner. Thank you.